Okay, so one kind of problem that you're going to want to know how to do on the exam, and these are common, multiple choice questions. You've seen them already. Is what I call comparison problems. So you're asked to compare two things based on some information you're given. The easiest way for me to explain these two is to show you an example. So we have this situation here in problem one where Arlen and Betsy drop rocks from different heights. Betsy's takes 3 times as long to reach the ground, so we want to find, the height difference. So, or the ratio of the heights. So Betsy, so let's say time for Betsy, let's see, time for Betsy gives us height for Betsy, or that's how far it has to fall, and then time for Arlen equals 3 times the time for Betsy, and then we want to know, height for Arlen over height for Betsy equals what? Okay, so this is basically dropping stuff as a 1D kinematics problem. This is basically, it's Kate 2. I'm going to skip the V naught part. 1/2 AT squared. I'm going to go ahead and define positive G being down. So, or sorry, positive Y being down. So H is a positive number, and then we just get to put G in for our acceleration because acceleration is down. And there we go. So now what we have is we take this and we plug in our two situations here. So for Betsy, we get height for Betsy equals 1/2 G times time for Betsy squared. And then for Arlen, we get height for Arlen equals 1/2 G time for Arlen squared. Time for Arlen, oh, I'm sorry, this is wrong. Time for Betsy equals 3 times time for Arlen. So what we want to do here then is plug in, let's see, I'm going to take the HB thing. See, I've already done this. This is why you practice these things, because I'm forgetting how to do these. So 3TB squared, or sorry, if TB is 3TA, we plug it in square, you get 9TA squared, okay, which is going to equal 9 times 1/2 GTA squared, which you will notice is equal to the height for Arlen. So this is going to equal 9HA. So the correct answer, HB equals 9HA, the correct answer is 9. Okay? If this seemed a little like scattershot, like I was kind of fumbling and stuff, yes, it was, because I'm just trying to show you how to do these problems, and I forgot exactly how to do them. If I were going to take a test and I were worried about my performance, I would practice some of these. The more you practice them, the smoother you'll get, and the easier it'll be. So there are some in the review, WebAssigns that you can practice on. So here's another one. Just I'm going to show you this. Stop it and do it yourself if you want. 2 cars on a freeway have identical momentum, but car A has twice the mass of car B. So what's the ratio of their kinetic energy? So PA equals PB is what I'm going to do here. And then what I can get is that mass of car A times speed of car A, or velocity of car A, they're both in the same direction, so it doesn't matter, equals VB, excuse me. And we know that kinetic energy is going to involve M and V, right? So if we know that car A has twice the mass of car B, then we really want to just find what VA is in terms of VB. So I'm going to plug in 2MB here for MA. VA equals MB times VB. And what that gets me then is that VA is going to equal 1/2 VB. So then I can go and say kinetic energy for A is 1/2 MA VA squared. And kinetic energy for B is 1/2 MB VB squared. And so how do I want to do this? Let's see. I know that MA is 2MB and VA is 1/2 VB. So what I can do there is say KA is 1/2 times 2MB times 1/2 VB squared. And then you get the 1/2 times the 2, cancels out, you get 1/2, 1/2, and you get kinetic energy of A is equal to 1/4 MB VB squared, which is equal to 1/2 of the kinetic energy of B. So KA over KB equals 1/2. Another way you could have done this, which I will just show you briefly in purple, is you could have found, you could have said momentum is mass times velocity, and kinetic energy is 1/2 mv squared. So let's suppose we just wanted to keep this, we wanted to get velocity out of there. So if you take p squared, you get m squared v squared, and to get that to be kinetic energy, you divide by 2m. Okay, and you'll find this is equal to kinetic energy. So kinetic energy is equal to p squared over 2m. And then what you can do very simply is say Ka over Kb equals p squared over 2ma. They both have the same momentum. That's why I can do this. So, and then p squared divided by 2mb. And then what you get is Ka over Kb once you do all this cancellation. And this is tricky because this is denominators in the fraction. So this is denominator of the numerator. This is denominator of the denominator. So what you get is Ka slash Kb equals the inverse of the ratio of masses, right? And so then car A had twice the mass of B, so this is going to come out to be 1/2 as well, just like it did up here. So there are different ways to go about this. The important thing is to practice some and find a way that works for you, because you will see these problems on the exam.